Welcome back, everyone, to the 2025 Innovator Summit. Next up, we have an awardee spotlight with Doctors Park and Jayaraman, who will together won an NAM Catalyst Award in 2023. Thanks so much for both of you for sharing your work. Please take it away.
Good morning. It's a real pleasure for Dr. Park and me to be here to share the work that we've been doing following the Catalyst Award, which is titled Enhancing Health Longevity of Individuals with Limited Mobility. Just a little bit about ourselves. I'm a faculty member at Georgia Tech, and our research has been at the intersection of computing and textile engineering and material science and engineering. And our lab is primarily focused on how we can use innovation, technology, and materials to enhance the quality of life. So that is exactly the kind of work that we do. And Dr. Park, my colleague who's been working with me for quite some time, has an excellent background in terms of being a Master of Fine Arts, as you can see on the title slide here. And she has a PhD in material science and engineering. So she really nicely combines form and function, so which means she is focused on both the human aspect of what exactly is needed from a form standpoint, but also from a functionality standpoint. And it's a real pleasure for us to talk about how we can use engineering and technology to be able to enhance the quality of life for people with limited mobility. And this is what Dr. Park and I would like to share in the next few minutes that we have. We want to talk about something called pressure injury, or also known as pressure ulcers, and we want to talk about the challenges. What is the current solution? And then when we applied for the Catalyst Award, what were our key aims in terms of what we wanted to do, and what are some of the fundamental breakthroughs that we have had, and what have we done post the Catalyst Award in terms of attaining additional funding and kind of proving that this technology is something that's really going to change the future of pressure injuries. Just to give you an idea of what a pressure injury is, essentially what happens when you're sitting for long periods of time, let's say a person who is sitting in a wheelchair, even office workers who've been sitting for long periods of time, what happens is the bony prominence, or if we take a senior citizen, which is one of the key focus that we have, is when you're lying in bed for a long period of time, this bony prominence comes in contact with the surface, and because of that, there is something called a pressure injury. And that contact between the bony prominence and the surface causes the skin to get messed up, and that leads to injuries, and that's why it's called a pressure injury. And what Sungmee and I call a perfect storm of pressure injury is you've got pressure, and then you've got moisture. And when you have moisture, the skin becomes very, very soft. And then if you try to move the person, the typical process is to move the person periodically. And when they move them, especially if you're sitting in a wheelchair and you try to move somebody, you're going to be sharing the skin. So our whole idea was this is something called a never even, that's not supposed to happen when a patient is in a hospital or sitting in a wheelchair. What can we do about this? And what are some of the real world implications of pressure injuries, right? Health longevity is affected by mobility. In other words, if I am mobile, then I can pursue whatever opportunity I want from a job standpoint, and my quality of life is going to be great. But if I'm confined to a wheelchair, because about over 3 million people in the United States are sitting in wheelchairs on a regular basis, and on top of that, if some of us have a spinal cord injury, that significantly affects our quality of life. Because if you have spinal cord injury, you don't have any sensation below your waist, and so the chances of pressure injury or PI are significant. And the current process or the current solution is, to move the individual when there is pressure over a certain period of time. And these are some of the statistics here that tells you that essentially a pressure injury is going to affect both the physical aspect of an individual and the psychological well-being. So we said we needed a solution to mitigate the PI. And here are some financial aspects of pressure injury. In other words, we use the Catalyst Award in terms of addressing a real world challenge that's going to affect health longevity. And if you look at it, it affects both the quality of life, and there are some deaths because of pressure injuries. And so it's not just the fact that it's morbidity, but it's also mortality. And the United States, we spend about $26.8 billion on taking care of hospital-acquired pressure injuries, which is a significant amount of money, especially when we talk about reducing healthcare costs. So what are some of the current solutions that are available? If you go to a hospital, they move the patient every 2 hours. They reposition the patient so that the same point is not in contact with the surface, and that way you're able to mitigate the pressure injury. But the key thing here is there is no unobtrusive way. You can put a whole bunch of sensors under the body, but that potentially could cause a pressure injury. So we are not able to gather data in terms of why we have this 2-hour pressure rule of thumb. And so everything is done based on practice as opposed to evidence-based. And today, with advancements in machine learning and AI, what we want is big data that we can then harness. And if you're sitting in a wheelchair, you're supposed to be moved every 15 minutes. And when we had COVID-19, caregivers could not reach their patients and individuals. And so it was a big, big challenge. And today, if you're sitting in a wheelchair, these are some of the solutions where they have these kinds of cushions or an air cushion that will kind of what is called offload. In other words, take the load away from the sitting bones or kind of move the load, shift the load across the surface. These are some of the other solutions, but what I want to focus on are the key gaps here. Most of these solutions focus only on what is called pressure monitoring, and they don't take care of monitoring the moisture, which, as we saw in the earlier slide, is very, very critical when it comes to pressure injury. And there's no targeted intervention. In other words, if a baby is lying down and only the head needs to be moved, then there is no such targeted intervention. The caregiver is not told, hey, the head does not move for a long period of time, or the torso is not moved for a long period of time. So then they generally end up moving the patient, which might be very difficult when you have a lot of instruments on the baby, monitoring the baby, or the person is lying down for long periods of time. Most importantly, all these things are viewed as devices. It's not something that's unobtrusive and really kind of like a real bed sheet that you have in the hospital. So this is the eye-popping slide, but we are presenting this one to show you how significant the NAM Catalyst Award is in terms of helping us address a very important problem. These are some of the solutions in the market today. As you can see here, most of these are no, and our technology is something called the pressure injury prevention system that we are developing, which is what we call the new gold standard. So we are able to monitor the pressure, we are able to monitor the moisture. It is data driven and it's a personalized intervention. So the caregiver or the nurse is told exactly what they need to do. And it's unobtrusive. It's like a typical bed sheet. It's conformable to the shape. And so in short, it is the innovation that we've been working on. So that nicely leads into the aims that we have for the NAM Catalyst Award. Our goal, our long-term vision is, can I make pressure injury a scourge from the past? In other words, people in the hospitals or people in nursing homes or people sitting in wheelchairs should not have to worry about PI. And that's the kind of breakthrough research that the NAM Catalyst Award helps us pursue. So we strongly believe that investment in prevention is a lot less expensive than the cost of treatment. And what Dr. Park and I wanted to do was we wanted to develop an unobtrusive platform for doing predictive analytics so that we can prevent the occurrence of pressure injuries. So those were the key aims that we had for our NAM Catalyst Award. And since then, what Dr. Park and I have been able to accomplish is quite a bit. So what we first and foremost did was we created a fabric-based sensor network. This is a kind of research that we've been working on for the past almost 3 decades, when we created the whole field of what is called electronic textiles or e-textiles or smart textiles in the same laboratory where this wheelchair is located. Excuse me. Essentially, what we have is a network of fabric-based sensors here that is able to monitor both the pressure and the moisture in real time. This is not something set a priori. We are able to monitor in real time, and based on that, we have modified the wheelchair to have a bunch of actuators here that will move up and down to relieve the pressure at the specific point. So we are not moving the entire patient sitting in the wheelchair, individual sitting in the wheelchair. We are targeting the intervention. So for instance, the sitting bones, the person has been sitting for a long period of time. We are relieving the pressure there only. At the same time, we have built fans under this one here so that you're able to dry up any moisture that might be there. Because when a person with spinal cord injury or wheelchair is sitting for a long period of time, we also sweat in our seat. So we want to get rid of that one. And thirdly, since the movement is up and down, we don't have any shear forces occurring when the individual is being moved. So through this invention, through this technology, we are able to do targeted intervention, and we have addressed the perfect storm of pressure, shear, and moisture. We've got a lot more slides, but this kind of encapsulates the breakthrough in our solution. We've got these fabric-based sensors here that are gathering the data in real time in terms of what is the degree of pressure, what's the duration of pressure, whether there is moisture, and our algorithms are built in so that depending on the person who's sitting there, because the weights change, the bottom profiles change, so we are able to customize the degree of intervention in terms of where exactly you need to intervene. And we've got built in an app that will tell you exactly where the intervention needs to occur. And then the heat map also shows us in terms of how the intervention has occurred. So since this is very, very small, we've got a slide here. So when the person is sitting, in the sitting bones here, you see the pressure is 460. This is in units, what is called the ADC units. And the pressure in the sitting bone is 515. And the actuators are at size 50 and 50, at location 50 and 50. So over a period of time, the pressure is high. So our algorithm, what it does is it lowers the actuators here. So it's gone down to position 30. And as you can see here, the pressure from 460 has gone down to 374. From 515, it's gone to 422. But more importantly, the pressure that was here has been distributed to the sides here. So that means it has gone down, it has gone up from 363 to 398. And so basically what's happening is through this technology, we have been able to create an unobtrusive platform for predictive analytics. Plus, we are addressing both pressure, moisture, and the shear. And most importantly, as you saw on this previous slide here, we have what is called both immersion and offloading, which are the two technologies that are independently available in the market today. So that's been a significant breakthrough in terms of what we've been able to accomplish this. And looking ahead, what we have now is the ability to gather foundational data for machine learning, because just by putting this fabric on the wheelchair or in a bed, we are able to unobtrusively get the data, because right now everybody talks about every 2 hours you need to move, but now we have data to say why 2 hours, more importantly, which part of the body needs to be moved. And so this is going to be, we believe it's a breakthrough innovation here with practical application, which will impact the cost of healthcare in our country. As we all know, it approaches close to about 20% of our GDP in the United States. And so our breakthrough technology, thanks to the NAM Catalyst Award here, is it will promote health longevity and enhance the quality of life for everyone. And so after this research here, what we have been thinking about is how can we broaden the scope and impact of this technological breakthrough? Because that's what the NAM Catalyst Award lets us do, is it's given us a pathway. And so where do we go from there? And this is what Sungmee and I have been on. Initially, we said, let's go and talk to the Veterans Administration or the VA in terms of, can we take this technology and deploy it and be useful for the veterans who are having spinal cord injuries, or as senior citizens, many of them are in wheelchairs. They were extremely helpful and cooperative in terms of helping us understand what the needs of the veterans are. But funding, as we all know, has been a big challenge. So this is a classic what Sungmee and I call the chicken and egg conundrum, where we have this brilliant idea and we need funding to make it go further. But then when we ask people to show us the money, they say, show us the results. So that's what we were kind of going through since having these breakthroughs here. And then we always knew that pressure injuries are affecting everyone in the continuum of life. It doesn't matter if you're a newborn who is in a pediatric ICU unit, or you're an individual sitting in a wheelchair, or you're senior citizens in a nursing home, because anytime, or people sitting in as programmers who sit for long periods of time, or office workers who sit for long periods of time, or even drivers on trucks driving long distances. As long as you're sitting in the same position or lying in the same position, you're having that contact, and that could potentially lead to pressure injuries. So we started talking to other, obviously we talked to the National Institute of Aging and NIH and NSF and all the other opportunities for typical funding agencies that we could think of. And everyone said it's a great idea, but money was kind of hard to come by. And so we talked to our neighbors here at the Children's Healthcare of Atlanta, and they were very interested in this, because if you think about it, if you're able to enhance the quality of life for the baby, then you are increasing their health longevity. In Sungmee's opinion, in my opinion, health longevity doesn't begin when you become 60 plus, but it begins it is all through your life, especially when you're a baby. So we were able to get a significant amount of funding to be able to enhance the system and test the system at CHOA. And so we are right now.
So let me pick it up from what Sundaresan said. So since then, we are doing this testing at the Children's Hospital with the babies, the babies who are in the NICU and the PICU, which is the neonatal, and also the pediatric. So we have the plan on going to do on the the pilot testing on November 2025. Actually, he has I do not have slide. Okay. Hi. Okay, I'm sorry, we lost the Sundaresan. So anyway, so we plan to do the clinical testing this fall, and we're gonna do the like real baby testing with using this system. So end of this testing, what we like to do, we like to prove that we can gather the pressure moisture data, and also we like to get our system when we can give an alert to those caregiver or the nurse, so that they can take care of the babies who might have prone to the pressure injuries in the future. Other than move the whole body, we like to give the information of which body part, for instance, like whether the baby needs to be turned the head more, or the torso, or the leg, or the arms. Like this, we like to give more information, and more to that, we like to use the big data analysis, and then also we like to implement the machine learning into that. So later we can customize to each baby to monitor those are the pressure injuries of the individual. Okay. So this is our presentation, and we always say the welcome to have anybody who is interested in joining us for the project, and also any the VCs or any other company who is interested. We always welcome. Thank you.
My apologies, my computer just crashed, and it says I have to take it to the shop. It's a new one. My apology.
Oh, no worries. I'm glad that Dr. Park was able to step in. But thank you both so much for a really interesting snapshot of your project. So innovative, and we're excited to see where it goes next. So thank you for sharing. Now we'll move into a short break, and when we come back, our panel on addressing social isolation through innovation and healthy longevity will begin. It will feature a cross-section of global awardees. Please stay tuned. Thank you.
Thank you.
Thank you.